So, hello everybody. My name is Samuel Pereira. I'm speaking from Brazil. I have now almost 2 years of experience with Elixir. And today I want to talk about gRPC. And I want to say that I hope everybody can enjoy this talk. So if I'm talking too fast or too slow, or if my English is not clear enough, please let me know and I will adjust to please you. And okay, so why I thought that gRPC would be a nice thing to talk about. I know a bunch of great developers who have years and years of experience, and they have heard about gRPC, but don't really know how it works, what its advantages are. And I personally only came to know gRPC very, very recently because I work in a company called Swap. We are banking as a service. And here in Brazil, we have a payment method that's called PIX. And the transactions need to be done really, really fast. Otherwise, it will time out. So one of our tech leads started using gRPC so we can we don't have this problem of timeout. And this is how I came to meet gRPC, and in my opinion is a very powerful tool to use for communicating between the microservices in the backend. So I think we can start with what RPC means, because I believe most people know that G stands for Google, but what's RPC? So RPC means remote procedure call. And that means that if you have a client and you can call a method, a function in the server without knowing its implementation or without knowing any of its inner workings. So let's say we have a function like get user, update user, which is on the server, and you can call it from your client, and you get a return without having the function in your computer. So that's basically what remote procedure call means. So it's a client-server communication protocol. It's when you call methods on remote system from your local system. And RPC is not something new. The term was coined in 1981, but it dates back from the 70s. Okay, so what about gRPC? So gRPC is a Google Remote Procedure Call, and it's an open source framework developed by Google in 2015 to enable
Sorry,
the
Samuel.
RPC.
Excuse
Yeah,
me.
sorry.
I think you are not I think you are not screen sharing. I was
Oh,
thinking this might be just an intro at
oh,
first,
okay.
but
I'm sorry. I thought it shows here that I'm screen sharing. I'm sorry.
oh, now we can see your screen. Right, that's great.
Okay, I'm sorry, guys. I really apologize because for me it shows that I'm presenting, but I was not. Okay, so here it's the remote procedure call picture that I got from the internet to show how it works. And I don't think you lost anything because it was just uh, it was just here the beginning of the presentation and this picture to show how the remote procedure call works. Okay, and what gRPC is. So gRPC is Google Remote Procedure Call, and it's an open source framework developed by Google in 2015 to enable remote procedure call style of communication. And it's a very modern implementation of RPC thinking of today's problems. And it's also part of the Cloud Native Computation Foundation. That's the same company that takes care of Docker and Kubernetes. So in my personal opinion, we can be sure that gRPC is being taken care of. Also, one of the main advantages of gRPC over REST is that gRPC uses the HTTP 2.0 protocol, and REST uses 1.1. So this newer protocol was launched in 2015, and I will show later on the presentation its main differences. But like with this protocol, when we are transmitting data, we are transmitting bytes, binaries. So the payloads, they are a lot lower, like smaller. They're a lot smaller than with JSON, for example. And also it's a lot faster for our computers to parse it, since they are bytes and not plain text. Also, gRPC is low latency, and it supports streaming. It's language independent, and with gRPC, the full form of communicating, it's by protocol buffers. And I will show you that we have a proto file that it's language agnostic, and we can use a single file to export code for any language you want. So let's say if you have 100 APIs in our microservice architecture, with a single proto file, we'll be able to export to Java, Ruby, and Python, wherever you're using. So this is very good. And also, all your communication will be done with the HTTP 2.0 protocol. So what are the modes that we can use with gRPC? We have the unary, which is when the client makes a request to the server, and by synchronous, you get a response. So that's the same as REST. But we also have server streaming. It's when the client makes a request and it gets a string of a response back. So this is very good when you want to do some asynchronous call, when you want to respond lots of data, large files. So this is very nice, and you don't have that with REST. We also have client streaming. That's the opposite of server streaming. It's when the client is making a string of requests. And we also have bidirectional streaming. That's when both the client and the server are streaming data. And one thing that I think is very nice in gRPC, it's that you can cancel your requests. So with REST, if you make a request, there's no way you can cancel it. Like, you can wait for it to time out, but that's it. With gRPC, you can cancel it. So I think with streaming, depending on the situation, you can use that on your favor. And so what's protocol buffers? With gRPC, you can use JSON, XML, and other types of data to make your requests. But by default, gRPC uses protocol buffers. And this I got from the official documentation, and it says, protocol buffers are Google's language neutral, platform neutral, extensible mechanism for serializing structured data. Think XML, but smaller, faster, and simpler. And like I mentioned before, protocol buffers use binary data. So it's a lot less bandwidth on the network. And I got here an example of a simple payload. So here it's a very small payload. You have age, first name, and last name. And this payload in JSON would be 55 bytes. And the exactly same one in protocol buffer would be 20 bytes. So that's almost 3 times smaller. And I know if you think like 50 bytes, 55 bytes is not much, and that's true. But like for large payloads and or for hundreds of thousands or even millions of requests, this will definitely make like a huge difference. And there is lots of benchmarks on the internet comparing gRPC and REST, and gRPC can be 7 to 10 times faster than REST. So I think it's important to bring some differences from HTTP 2.0 and HTTP 1.1. And this newer version was launched in 2015, same year as gRPC, and it was based on SPDY, originally developed by Google. It has high-level compatibility with the older version. It's low latency and a lot faster than the 1.1 version. Also, the headers, they are compressed, so they are smaller. And one thing that I think is pretty cool, it's that with gRPC, you establish a connection between the server and the client. And with the same connection, you can make lots of requests. You don't need like to have one connection for each request. And also you don't have to wait for a response if you want. You can do lots of requests in parallel. So this is pretty cool. Also, we have a server push, and server push is like when you make a request, the client makes a request to the server, and the server knows that you will need some type of information, even if you don't ask for it. So to make things faster, the server will send this information to you, even that you didn't ask for it. And pipelining and multiplex, it's basically when you have one connection and you can make lots of requests in this connection. So I know that like with HTTP 1.1, if like let's say you open a website and you have to get the HTML, CSS, images, and everything, you're gonna have to make lots of requests, lots of connections, and we don't have that with 2.0. And if anyone have any questions, just let me know, please. Here I made a quick recap of what we talked so far to make a comparison between gRPC and REST. So like I mentioned with REST, I know that we are not required to use JSON, but from my experience and from what I have seen so far, pretty much every time we use JSON with REST, and with gRPC it's binary data. Also with REST, you are stuck to unidirectional requests. So you make a request and you get a response in a synchronous way. With gRPC, we have that, but we also have bidirectional, we have streaming, and we have asynchronous. REST is high latency and gRPC is low latency. And one thing that personally I think it's very, very good in gRPC, it's that you have a contract. So after this, I will make a little application in Elixir and you're gonna see better. But with gRPC, you create a proto file and there you're gonna define like, okay, I wanted to expose these methods like get user, update user, and these methods, they are gonna receive this type of request, or where you're gonna send like a name, which is a string, another Boolean field and everything. And the response is gonna be this struct of user that have these fields. And the protocol itself is gonna take care of that. So if you make a request without those fields, it's not even gonna happen because the protocol knows that you are not respecting this contract. I know that with REST, you can like have a documentation and say, hey, this endpoint expect you to send this, and we can answer this and this and this, but there's no guarantee that this is really going to happen. So you need to prepare your application for all these corner cases, for everything that can happen, or otherwise a bug might happen or something like that you didn't expect. So we do have this contract in gRPC, which I know some people don't like, but in my opinion is very good. And uh, and lastly, this is like I think this, but if this is not true, please let me know. But from what I have seen, REST APIs, they are usually like stuck in CRUD. And in gRPC, I think because of the style of communication, which is the remote procedure call, you kind of have more freedom to design your applications. So I saw that someone asked if there is a huge performance difference from HTTP 2.0. From what I know, from what I have seen from benchmarks, it can be 7 to 10 times faster. gRPC can be 7 to 10 times faster than the older version. So I think it can make a huge difference. Okay, so so far I have only talked about the good things, and of course, nothing is perfect, and especially in technology, there's not one thing that will solve all the problems. So here I listed some disadvantages of gRPC in my opinion, and the first one is that there's no, at least so far, there's no native browser support for gRPC. So I don't believe that gRPC is recommended to communicate the front end to the back end. Yes, gRPC works like a socket, exactly, Gisandro. And like, I mean, for the streaming part, it works like a socket. Yeah, it can work like a socket. Thank you. Also, another disadvantage is that gRPC is very new, so it's not widespread like REST. REST and HTTP 1.1, it was launched in 1997. So there's like a long time from when it was launched to now. And so it's like very widespread. There's like lots of tools to work with it. There is lots of resources for you to learn. And I think that if you start a project now, uh, chances are very high that every developer will know REST, will know like its pattern and everything. And chances are a lot lower that someone will know gRPC. But in my opinion, it's not hard for you to get the basics and get started. Okay, another disadvantage is that for now, gRPC has official support, if I'm not mistaken, it's 11 or 12 languages, and Elixir is not one of them. We have an official library that it's developed by José Valim himself and other people, of course. It's in 0.5 version, it's not in 1.0 version yet. So for now, we don't have official support from Google. And also, one thing that I think is very odd in gRPC, it's that from version 3.5 to and future versions, you can specify which fields are required and which fields are optional. But let's say that we have a string field that's optional, and the client doesn't send it in the request. Instead of you receiving new, you're going to receive an empty string. And if it's a number, you're going to receive 0. And if it's a Boolean, you're going to receive false. So I know that we use new a lot in Elixir, and it didn't happen yet with me, but I think it might have some situation somewhere that you have a problem where the person sends a 0 or a new, and you don't have a way to know if it was really new or if the person sent a 0 or false. So when you develop your application, you need to have that on your mind. Okay. I'm sorry if I talk too much, but I want to give like a nice theoretical introduction to gRPC and show its advantages. But now I thought about how to show how to do an application with Elixir. And my idea here is to give like to do a basic application. We only have like a get user service. It's just to show that's not complicated to do an application with gRPC. And also something that I always, when I work with Elixir everywhere, I've always used Phoenix. For me, it's like Phoenix and Elixir is kind of the same thing. But with gRPC, you don't need Phoenix to your application. So that's something that you get to know when you start you do an application with gRPC. So here I'll give the link to the official documentation of the gRPC library in Elixir. It's very
Can you guys hear me? I think we lost Samuel. I think I'm gonna try doing whatever I can to restore Samuel into the meetup. I'm sorry for the inconvenience. It's probably due to his some problems at his side with the connection. So I'll be trying to contact him. I think if the connection comes back at his side, he's gonna be back with us in a matter of a few minutes. So I apologize for the pause. I think the I don't think you are to blame, Leonard, for this. This happens, unfortunately. One of us was once hosting a talk inside a online conference, and there was a similar issue in the middle of a talk. And it also happens when you have strict time slots in this kind of conferences and so on. So when you happen to be restored um, into the connection, you might end up with a presentation which you have only 15 minutes or 10 minutes for instead of the original time. I'm gonna try contacting Samuel for some more time, because I just hope he's aware of actually being away from the meetup. So let's see if we can do anything about that. Oh yeah, the internet connection is always a pain when hosting online events. So I guess we'll try to wait for Samuel for some more time. I guess in the meantime, it might be a good idea to post questions to Samuel on the chat, regardless of whether we are able to bring him back into the meetup. It's something that he might answer either now or later. We can obviously pass them over to him.
Hey,
Right?
hello. I'm so sorry.
You're with us again. It's great to hear you.
Okay. I deeply apologize. It rained a lot here yesterday, and the internet is very bad. But I connect with my cell phone. I'm sorry, people.
That's okay. We were happy to wait for you. It's obviously not a problem for us. We know this happens. Um, I guess no one has left the meeting in the meantime. So we all were waiting for you eagerly. So take your time, and you can just continue your presentation. So the stage is yours again.
Thank you very much, Mike. You are really nice, and I deeply apologize again. So, can you see my screen? And okay, awesome. So I think I stopped it here. I'm gonna give a link to the official documentation, but you basically need to install protobuf, follow the instructions for your operating system, and then you need to install protobuf in your Elixir application. And also you don't need to use Phoenix. You can have a plain Elixir application. And you need to add the dependencies to your depths to your dependencies list. So the buffer and package independent. So you create a profile in so far the thing that you So you're not required to, but you can write a package name to make things more organized. And after that, you write your service name and the methods that you want to expose. So let's say like get user, update user, and so that's something how we handle binary data on the client side. So the application itself to for to write the humidable data, but when it's not the uh, as binary, so your computer is part for you. I'm gosh. Okay, good idea. Okay, so here, like I was saying, we have the proto version, the package name, which is not required, but it's nice to have things organized. And here in the user service, we define the name of the service, and also the methods that we want to expose. So for this example here, it's just a get user. So here's the contract that I mentioned before. You say, hey, the request is gonna have a get user request, and it's gonna return a get user response. So below we define the which is just the ID of the thing, and once enter or use to equal to uh, I'm, I'm sorry. So I'll try to move on. I think we're almost on the end. So hopefully we can get to the end. So these numbers here, the one, it's a convention that you follow a numerical order. So let's see if object uses another that would be a boolean or whatever. This would be number 4. The next one would be number 5 and 6 and so on and so on. And okay, with this proto file, we can transpile it to any language that we want. So if we have like a microservice architecture with lots of different languages, we can transpile this proto file and generate all the boilerplate code that we need. So with Elixir, we have to get this proto file and transpile it. So we type in this command here, the proto c elixir out, and in the end, it's the location that we want to keep the files. So in this example, it's our users API. And when you transpile this proto file, it will generate a module, a file with lots of modules in the same file, which will have everything that we defined in our proto file. So the get user request, the get user response, and the user object. So you can see here in the lines that the first one is the get user request, which it's an ID of type integer. And here in the dev struct, you can say that the ID, it's the default is 0, which is what I mentioned. When you don't send a field, it's not going to send it as new. It's gonna, if it's optional, it's going to send a 0 when it's a number. Okay, next, and in the same file that we transpiled with that proto file, we have the user response that we defined that's gonna respond with an user struct. And then we have the user struct, which has an ID, a title, its a name, sorry, and email. And this is all in the same file. And finally, we have the stubs, which it's like the client and the services that we're gonna use. Okay, so now that we have defined the proto file, we have transpiled it, we need to make our servers setup. So here in the config file, we need to put this here, config gRPC start server true. And then we need to define an endpoint module and make use gRPC endpoint. And this intercept, it's like the plugs that we use in Phoenix. So it will intercept the request, so we can use it to make authentication, login, and everything. And this is pretty much the plug that we have in Phoenix. And below we have the run and the server. So I think this is very nice because we have defined only a get user method. But let's say we had get user, update user, delete user, or anything. This would be everything under this server. So it's a lot cleaner than the router module. Okay, and this would be like the controller, where we make it like a very clean module. Just define a function get user, which will receive a struct of the get user request that we defined. We will get the user and we will create a response. That's like everything that we need. And then there's the also option if you can find the user. Okay, so that was the part of the server. And now I want to show the part of the client that will make the requests and use the methods that we exposed. So we transpiled that proto file, and then we just create a client with a get user function. And how it works is that we have a URL that will make the requests, and we establish a connection with that URL. That's our channel there. And then we create a get user request struct that we defined in the proto file. And then we just use that function get user, pass in the channel and the request, and you get the response just like it was defined in the contract. So if we fire up an IX section and we call that function, passing like an ID 1, this is going to be the response. So of course, this was a very basic application, but the intention was just to show that It's not hard to use gRPC. It's very simple. And maybe for your applications, you can try to use. It's not something hard to learn, and it has lots of advantages. So again, I'm very sorry for the connection problem. It was out of my control, and I hope you could enjoy the presentation and learn something. Thank you very much, everybody. And if you have any questions.
Yeah, thank you, Samuel. This was a great presentation, even though we had some technical issues. That's life. It happens. This is just that's just some things we don't have under our control. So it's perfectly understandable. In an online meetup, which gathers people from all continents. So yeah, thank you very much for your presentation, and let's start a question and answer session. Feel free to ask any questions you have in the chat, and I'm going to present them into the. I'm gonna present them uh, into the webinar in a moment. So, all right. The first thing was I think some of the initial questions might have already been answered during the talk, but nonetheless, we might repeat them. Okay, so Rafael has asked, is there a huge difference between from HTTP 2.0 to gRPC in comparison to HTTP 1.1?
So, like I mentioned before, there's a lot of benchmarking, and I'm sure that it will vary from case to case, but it's usually 7 to 10 times faster the newer version than the older version, and it's a lot less data that you are transmitting to your network. So you can also say that it's greener than HTTP 1.1.
All right. Thank you for the answer to this question. And the next one is whether gRPC works like a socket. And I clearly recall this being referenced in the talk, but we can elaborate this a bit here.
Hey, Gisandro. I believe that when you are using the streaming method of gRPC, where you establish a connection with the client and the server, and you are having lots of requests, even like you can have coming from both sides, I believe it kind of works like a socket. But it can also work like just a simple synchronous request.
Okay. Thank you for this question, Gisandro, and for the answer, Samuel. And then the next one is from Vabihav, who's asking how we handle binary data on client side.
So the binaries, the bytes, they are only bytes when they are being transmitted through the network. When it arrives to your application, it will arrive as a human readable data. So the protocol itself handles it for us. We don't have to worry with these low level things.
All right. Thank you for the answer. And the next question comes from Leonard. He's asking, is it practical to use gRPC to communicate with a mobile app?
Hey, Leonard. I'm sorry that I don't have the answer for you. But I know that mobiles have like a lot less power than computers. So since we use binaries, I think that's a good thing. But I'm honestly not sure if it's practical or not.
All right. Thank you very much. And the last one so far is from Milan, who's asking, what is the performance difference in encoding or decoding between protobuf and JSON, for example? And I'm not sure if you're referring to JSON as the Elixir library or just the JSON standard itself. But okay, you are referring to JSON as a library. You're right. So that's the question from Milan.
Oh, I have never done like a benchmarking to know this answer, but the other day I was watching a talk from some people that worked in like do you know like Expedia, that they have like they claim to have like cheap flights and everything, and they were showing their payloads because it had like lots and lots and lots of information about hundreds of flights, and it was like in JSON. It was very very huge, and they had like lots and lots of problems. And I know that's part because of the JSON is the plain text. So I know that it's it's slower with JSON, but I don't have the exactly numbers.
Okay, thank you for your insight on this. And the next one comes from Vabihav again, and he's asking whether it is easy to consume if we use gRPC API in something like with React. I think this question is related to the one about communicating with clients and mobile apps in a way.
Okay, I know that there is official support to JavaScript, so I believe it's even better than with Elixir, but I have never used it.
Thanks for this answer. Um, is there Are there any other questions from you guys? Um, yeah, we have a question from Rafael. Thank you for the presentation. Is gRPC a viable solution for services communicating in a local network?
Thank you for your message, Rafael, and I believe that it's viable, and I believe where gRPC shines the most, it's the in the communication between microservices in the backend. So I'm sure that's a viable solution for a local network.